Now we'll go to the next topic. The topic is called AI techniques. So AI technique is a method that achieves knowledge. What are the three main parts of the AI techniques? The first thing, you should have a search. Search means finding or searching the solutions for the given problem. There may be n number of solutions. So you could find out all possible solutions and then get the best one. Use of knowledge. So capture the knowledge about the real world. From the environment, you should search for the input, collect all the data, and then generalize the properties of the data. Okay, so when you develop a knowledge, okay, show them the important features alone and hide the unimportant features. That is known as abstraction. So search, use of knowledge, abstraction. So data abstraction we also studied in OOPS, right? So hiding something, right? Unwanted features. The same thing. Abstraction is when you collect information about the data. So the data may have n number of features. All the features are not necessary for developing a solution. Okay, so show them important feature or separate the important features, whereas you omit or hide the unimportant features. Okay, AI applications. Okay, it is spread from medical to manufacturing, right? As we have seen earlier, AI deals with the variety of problems, right? Various day-to-day problems, different identification and authentication problems, same security systems and decision-making classification problems and cyber physical systems. There are independent or cross-domain problems is also there with AI. So in all these problems, AI techniques to be used. Okay. So where you say intelligent, intelligent requires some knowledge. So knowledge is nothing but the information about the data, right? So when you say about data, what is the three V's of data? Volume, velocity, variety, right? Volume, variety, velocity. So volume is there may be huge amount of data, right? So each and every minute, every day, every second, the volume of data is generated from KB to terabyte and it goes on, right? So there are large volume of data and it is hard to characterize accurately, right? So it is constantly changing. Speed is also there. Okay, and variety of data is there, right? Volume, variety, different variety, audio, video, text, right? So many varieties of data is there and it is constantly changing, right? So what are the characteristics of AI techniques? So what it requires? So knowledge, as we say, knowledge should capture generalization. Say I should identify some properties from the data. Okay, so I should come for a generalized conclusion. Okay, it can be understood by the people who must provide it. It can be easily modified to correct errors, or it can be used in variety of situations. Right? These are the four characteristics of AI. Okay, so four characteristics of AI. What are the challenges of AI techniques? So as I told earlier, need to analyze the data and data are very huge, right? Huge volume of data is there. Analysis should be followed by the mapping of data with built-in knowledge. So we also have some knowledge about the data. So we should analyze based on the knowledge what we have, or you could also collect some more knowledge. Dealing with constantly changing, right? Constantly changing scenarios and situations. Identification of relevant data, relevant features, which are very challenging in AI techniques, right? The top four applications. So we have seen many applications. What are the top four applications of AI? Machine learning, NLP, natural language processing, automation and robotics, machine vision. So these are the top four AI techniques. Okay, so after we see what are the characteristics of AI in challenging AI techniques and everything, now we'll go into the topic called problem solving with AI. So what is problem solving? So problem solving deals with finding solutions to particular unknown problem. Okay, we don't know the solutions, or we want to computerize the solutions, right? So finding solution to the particular unknown problem. That is called problem solving. So problem solving, first we need to generate the solution by keeping the environment conditions, right? So first generate so many solutions and identify the best one. See some of the problem solving with AI. Okay, say it may be from games such as Sudoku, chess, or tap-toe, traveling salesman, real-time problem. Okay, finding a shortest path from one place to the other place, or the Google Map. Okay, previous days and all, we used to ask the neighbors or the shopkeeper to reach that particular place. Nowadays, everyone with a smartphone, we are able to reach the particular place without asking anyone, right? So, traveling salesman problem, Tower of Hanoi. Okay, so how to arrange the disk on top of the other disk. Tower of Hanoi problem that I've studied in data structure, and water jug problem. Okay, so we'll see all these problems one by one in the end of the first unit. And queen problem. Okay, so these are the some of the areas where we could use problem solving techniques, right? So as I told you, so problems, you need to find out the solutions. So what are the steps you have? There are 5 important steps we have. First one, define. Okay, so first one, define the problem and then analyze it. Okay, so identify what are the input criteria and what are the environment is there, constraints are there. So analyze, identify all possible solutions and then choose the best solution and then implement the solution. Okay, so whatever I have explained, that will be there here. Okay, define, analyze, and then identify all solutions, then choose the best one and implement, right? So next, what are the categorization of AI problem? So AI problem is categorized as structured and unstructured, linear, non-linear problem. So what is structured problem? So structured problem, again it has two types, well structured and ill structured. In unstructured, it is I'll tell you one by one. Okay, so structured, unstructured, linear, non-linear problem. There are 4 categorizations we have. The first one, well-structured problem. So well-structured problems, this will yield a right answer. Okay, so this will yield a right answer. Commonly faced problems like uh, the structure is clearly defined. Okay, the evaluation criteria is clearly defined. There are ordered steps are there how to reach the final goal. Okay, so what is the initial state, what is the goal state, and what is a constraint. So everything is clearly defined. That is well structured problem. So for example, finding out the value of x from the equation y is equal to, or x is equal to, y is equal to uh, x plus 20. Okay, uh, where y is given as, say, 30. Y value is given as 30. Okay, so what is the value of x? So finding the value of x, calculating the speed of the ball when it reaches to the batsman, or tic-tac-toe problem, exo game. Okay, so you know what is exo game, right? So you will be placing x, opponent will be placing O. Then if you get triple X in row wise or column wise, you will be the winner, right? So X again, tic-tac-toe. Okay, so these are all an example for well-structured problem. So well-structured problem will have ordered steps. The structure is clearly defined. That means problems state is clearly defined, initial state and what is a goal state. So goal state is I should get 3x either in row wise or column wise or in diagonal wise, right? So goal state is known, and what are the constraint? So when I place x, opponent will place O. Again I need to place. Okay, so all the constraints are given clearly, right? So you will get either correct or incorrect. So outputs you will get definitely. Okay, yield a right answer, right? So this is called well structured problem. Ill structured. Okay, so the structure is not clearly defined. or the evaluation criteria is not clearly defined, or it does not have an ordered step, okay, it will not yield a particular answer. Okay, see, it will not yield a particular answer. Okay, so possibility of more than one answer depending on the situation, right? Depending on the input criteria, or depending on the current situation, okay, you may get different answer. Okay, so that is called ill-structured. Say for example, how to dispose the wet waste. Okay, so what is wet waste? It is depending on the perception, right? So I could say a number of methods. You will not know which one is correct also. Okay, you may not able to decide the correctness, right? How to identify the security threats in social gatherings. So they are all an example for ill-structured problems. Then the next one. Okay, difference between well structured and ill structured. As I told you, well structured are complete structured, defined, and it is unambiguous. There is no ambiguity here. Here it is incomplete and ambiguous will be there. There is stopping criteria or evaluation criteria will be there. Here there is no stopping criteria or evaluation criteria to reach a solution or to identify whether the solution is reached or not. Here knowledge is needed by the problem solver. It could be represented by the problem space. Problem space is nothing but input, output, intermediate actions, okay, operations, operators, everything is defined clearly. I'll be telling what is meant by problem spacing and problem formulations, everything in the next class, right? So everything is clearly defined. Okay, so here I may not know, probably something will be missed, or many sources of knowledge will be there. Okay, problem spaces will be there, so it's very difficult to identify. Here the operator are actions to be followed. So what are the actions, okay, to reach the final code? That is also defined clearly here. There are a variety of operations to reach the solutions will be there. So which one to be selected? Okay, or some solutions, okay, it will not reach to the goal state. Let's say for example, checkers, towers of Hanoi, chess, tic-tac-toe, theorem proving. Okay, these are all example for well structured problem. For ill structured, planning, management, document, and music compositions, right? So these are all an example for uh, ill structured. Okay, so we also told about non-linear and linear, right? So linear is nothing but there is a straight line, right? So by it can be solved by using linear equations, right? So here I have given an example diagram. See, there is a classification, right? So green and blue. So by using the linear equation, a straight line, I could easily classify into two groups. Here it's very difficult to classify, right? So non-linear problem which cannot be solved by using linear equation. So input and output is not linear. Okay, so it follows some other structure. So it is very difficult to solve, right? So these are the references